Hello, I'm Mrs. J, and today we're going to work on graphing a rational equation, a quadratic over a linear. So when we're doing these ones, first thing, domain. Domain, you look at the denominator and set it equal to 0. When we set it equal to 0, we get x cannot equal -1. So our domain is all real numbers except for -1. Now, if this was factorable, we would factor it and see if this is a vertical asymptote or an open circle. Since it's not factorable, it's a vertical asymptote. So there's a vertical asymptote at -1. Horizontal asymptote, you look at the degree. I'll just put it right here. The degree of the top is 2, and the degree of the bottom is 1. When the top is larger, there's no horizontal asymptote. There's a slant asymptote. To find the slant, you need to divide. I'm going to use synthetic division, so setting x plus 1 equal to 0. We use a -1. Then we have a -1, a 2, and a 5. First thing you do is bring that number down. -1 times -1 is 1. Bringing it down, we have a 3. -1 times 3 is a -3. Adding down, we get 2. This was x squared, so this becomes x. -x plus 3. This is the slant asymptote. So if I go to graph, my vertical is at -1. And I have a slant here. So y-intercept 3, 1, 2, 3, it's here. And slope down 1 over 1, down 1 over 1. Just like that. And it's an asymptote, so it is also a dotted line. Okay. Now we need to plot 2 points on each side of this. X and Y. So I need to plug in -2, -3, and 0 and 1. I'm plugging them into my calculator. Let's see. -x squared plus 2x plus 5. And you're just plugging -2 into the original equation and then plug -3, 0, and 1. So they're all 5. Make sure I did it right. -x squared plus 2x plus 5 divided by x plus 1. -4 minus 4 plus 5 over -2 plus 1 negative 5. Oh, I didn't put negative 2. Negative x squared plus 2x plus 5. I don't see a mistake, but I'm not getting the... Oh, I'm canceling those. Three. Okay. Plugging in the negative 3. Negative 3 squared plus 2 times negative 3 plus 5 over negative 3 plus 1 gives us 5. Plugging in 0 gives us 5. Plugging in 1, 6 over 2 gives us 3. Okay, just want to make sure I was getting the right answers. But you're just plugging them into the original, so then the points negative 2, 3. 1, 2, negative 2, 1, 2, 3 here. Negative 3, 5. 1, 2, 3 here. So my line is going like this. My other one, 0, 5. 1, 2, 3, 4, 5 is here. And 1, 3 here. So it's approaching that slant asymptote. But everything else is just the same as when we had a vertical and horizontal. Plug in 2 points. Let's try another one. Okay, 4x squared plus 18x plus 9 over 6x plus 9. Domain. Set the denominator equal to 0 and solve. So x cannot equal a negative 3 halves. That will be our vertical asymptote also. For the horizontal asymptote, we look at the degree. The degree on the top is 2. The degree on the bottom is 1. Remember, the degree is the largest exponent. When the top is larger, there's no horizontal asymptote. There's a slant. To find it, you divide. Now this one, I will divide this way. Long division. 4x squared plus 8x plus 9. Not nice. You know what? I'm going to try I think maybe the other way will be easier. For synthetic division, 6x plus 9 equals 0. 6x equals a negative 9. X equals Oh, we already did this. And -3/2. I wasn't thinking we did that here, so it'll come right from here. But that's how you find it, -3/2. And I'm dividing into a 4, 18, and 9. So -3/2 times 4 is going to be a -6, which is 12. And this is going to be a -18, which is a -9. We don't worry about the remainder. This was x squared, so our slant asymptote is y equals 4x plus 12. My vertical was at -1.5, so it's and the slant, I start at 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we go up 4, because our slope is 4, and over 1. 1, 2, 3, 4, so it'd be here. Or down 1, 2, 3, 4, and back 1. Down 1, 2, 3, 4, and back 1. And there's our dotted line. So we need to pick points on each side of the -3/2. Oops, I don't know why I put those so far apart. So for my slant asymptote, this was my y-intercept and this was my slope. Y-intercept hit here. I went up 4 and over 1, but I ran out of room, so then you can also go down 4 and back 1. Down 4 and back 1. Right, so here I could go with 1 or -1 and 0. Going this way I can go with -2 and -3. Plug them into the original equation. So we have 4x squared plus 18x plus 9 divided by 6x plus 9. Plugging in at -1, we have -1.7. Plugging in 0, we have 1. Plugging in -2, we have 3.7. And the last one is also a 1. So we go -1 and down, -1, almost 2. Then we go 0, 1. So our graph is going this one -2, 3.7, 2, 3.7. So about here. 1, 2, negative 3, 1. So it's really close to this graph. Kind of like that. This one should be a little narrower. I think more like this. But it's supposed to cross at 1. But what you do is you'll give them the points, and then they will graph the lines. That one. The other one is similar, but they have holes in them. So if we look at the graph, we have negative 3x squared plus 12x over x squared minus 5x plus 4. Okay, now what you want to do is, I don't know why that all of a sudden. I'm trying to shut this off. That's better. Okay. This is a plus 4. I don't know what's better. We need to find the domain. The domain is by setting the denominator equal to 0. Now notice these should both be factorable. On the top we can pull a negative 3x out, and we're left with an x minus 4. On the bottom it factors x minus 1, x minus 4. So for our domain, we look at the denominator. Yes, the x minus 4's cancel, but don't cancel anything until you find the domain. Okay, so we have x equals 1 and x equals 4. So our domain, x cannot equal 1 and x cannot equal 4. Then we get vertical asymptote and open circle. Both of these are possible, vertical asymptote and open circle. But this one cancels. That came from here. That means this one is an open circle. This one is still here. This is a vertical asymptote. So our vertical asymptote is x equals 1. Our open circle is at, what was it, 4. But we need to find the y value. To find the y value, plug it into the reduced form. So we have a negative 12 over 3 or a negative 4. So we have an open circle at 4, negative 4. And we have a vertical. We need to find the horizontal. The horizontal goes by the degree. The degree on the top is 2. The degree on the bottom is 2. When they are the same, the horizontal asymptote, you take those two largest degree terms and reduce them. X squareds cancel, y equals negative 3. So our graph, vertical asymptote at 1, open circle at 4, 1, 2, 3, 4, -4. So right here. Horizontal is at -3. It won't let me write the whole equation on the plastic. So we know this one's going to be in here. Graph the rational function. Okay. You should plug in 2 points on each side like we've been doing. I think it's just best. So we have our x and our y. So this is at 1. We can use 0 and -1. This is at 1. We can use 2 and 3. Plugging in 0, and you can use this form. 0 is 0. Plugging in -1. Positive, negative, -3/2. Plugging in 2. We have 6/1 or 6 negative. And then plugging in 3. -9/2. So 0, 0 is here. -1, -1.5 is here. So this one is here. The other one, 2, -6. So here. And 3, -9/2. So that'd be 4.5. Must be about here. And then I have that open circle. Try one more. Okay, factoring the top, x minus 4 and x minus 3 over x minus 4. Domain, x minus 4 equal to 0, so x cannot equal 4. So we could have a vertical asymptote or an open circle. Notice it cancels. That means that this is a open circle. Since there's no other ones, there's no vertical asymptote. So the open circle is at 4. To find the other value, we plug it in and get 1. So we have 4, 1. Okay, so for our open circle is at 4, 1. Now another thing you want to notice is there's no fraction left. So there's no horizontal asymptote either. This is just a straight line. Of course it's going. This is just a straight line at x equals 3. X minus 3. So we have an open circle at 4, 1. And then if we graph this, it goes down 3. And the slope is up 1 over 1, up 1 over 1. So since there was no fraction left, then there's no horizontal asymptote either. There is just an open circle and a straight line. And that's all that's to it.